Now in this example, we want to test the claim that the percent of dissatisfied customers is not 86%, and we're given some sample information. So first we identify the null and alternative hypotheses. The null hypothesis is that P, the proportion of dissatisfied customers, or the percent of dissatisfied customers, is equal to 0.86, and the alternative is that P is not equal to 0.86. So now we're ready to conduct our hypothesis test in the calculator, and I've rigged this so that there's a common error that happens, and I'm going to show you how you can fix that. So we're going to see what happens when things go a little wrong. So I click on Stat, and I go over to Tests, and I want to choose one prop Z test, because again we are conducting a hypothesis test about a proportion. You can see I still have the information from the previous hypothesis test, the previous example, and that information stays in the calculator until you change it, which can be helpful when you need to go back and change something, so that works. Okay, so what do we know from this problem? The null hypothesis said that P was equal to 0.86, so that's our value for P0. Next, we want to enter the number of successes, and that's not given in a straightforward fashion in this problem. We are told that out of 240 cards, 78% said the service was slow. So we know that 78% of all of them are the number of successes, but that doesn't tell me the actual number to enter here. I don't have to go out, though, to find out what 78% of 240 is. What I can do is just type this into the calculator here. 0.78 times 240. And when I hit enter, I get 187.2. Now, the number of successes, or the number of cards that said the service was slow, has to be a whole number. So I have to round this number the way we would normally round. And I'm going to turn this into 187. We round down because it was 0.2. The number of trials was 240, so I'll put that into the calculator, 240. And this is a two-tail test, so I need to choose not equals here. That's the alternative hypothesis. And now I go to draw. And when I press enter, I get an error, invalid dimension. So I just hit enter, that's my only option to quit. Now what's gone wrong here? If you click on y equals, you can see that there's a function graphed here. Now that's not actually a problem for us. That's not going to cause the error message, but it may cause a graph appearing on our graph. And so we always want this area to be completely empty when we're doing statistics, so I'll hit clear for that. Now the real culprit is this plot 1 being turned on. So I could go to stat plot by pressing second and y equals, but I can fix this from here. All I have to do is press the up arrow and press enter. Now I've turned off that plot 1, and I have to go back to my hypothesis test. So stat, left arrow, number 5, but we don't have to re-enter everything because it stays there. So now I go to draw again. Let's try again and see if that fixed it. And it did. So now my test statistic is negative 3.61, and my p-value is 3e negative 4. So this is given in scientific notation, and you need to convert that to regular decimal by moving the decimal point from where it is right now, which is just to the right of the 3. You move it 4 units to the left. So that gives me 0.0003. And that's a very small p-value, and you can see that here. The p-value, you don't even see what part of the graph is shaded. So that tells me that we want to reject the null hypothesis. And that concludes this test.